So continuing with linear combination, where you're basically adding the two equations to get one of the variables to cancel out. In some cases, when you try to add the two equations, the variables aren't going to have opposite coefficients, so there's not going to have anything to cancel out. So what you'll need to do is think about what that number would have to be so that the two equations would cancel out. So if I look at 3x minus 2y equals 6 and 2x plus 4y equals 20, I can see I have opposites here because one is subtracting and one is adding, but the numbers aren't the same. The coefficients aren't the same. So you could actually multiply one of these equations by a number, multiplying each term by that number so that it had a matching coefficient. So if I look at these three terms and compare with these two numbers, if this were a 4, when I add them, they'd cancel out. So to make that a 4, I would need to multiply by 2. But in order to keep that equation balanced, I would have to multiply everything by 2. So I would have to multiply this one by 2, and this term by 2, and this term by 2, making the new equation 2 times 3x is 6x. 2 times a minus 2y would be a minus 4y. And then 6 times 2 equals 12. I still have the exact same original equation. I just multiplied the same number by each of the terms to keep it an equivalent equation, just like you would do it when trying to find an equivalent fraction. You multiply by the same number to rewrite it. I essentially just rewrote this equation. It's still the original equation. If I were to graph this, it would still graph the exact same line, but now we can use linear combination to solve. So if I were to add these two equations together, so set up one big addition problem and add vertically 6x plus 2x is 8x. A minus 4y plus 4y cancels out to be 0. And then 12 plus 20 would equal 32, giving us a simple one-step equation, 8x equals 32. And if you divide by 8 to get x by itself, you'd find that x equals 4. Now looking to find what y is, you're going to take that value of x and plug it into one of the equations. I would choose the equation that you didn't change. So this one, plugging in 4, 2 times 4 plus 4y equals 20. 2 times 4 is 8, plus 4y equals 20. And then combining like terms on one side, so subtract 8. Inverse operations here gets us these two to cancel out, and 4y equals 12. And to get y by itself, right now it's showing to multiply by 4, so the opposite of that is to divide by 4, and you get y to equal 3. So this would be the solution for 3. That's the intersecting point where those two equations cross. But again, always check your answer. So checking with the first equation, use the original equation. 3x minus 2y equals 6. And put in 4 for x and 3 for y. And I want to see if that equals 6. So 3 times 4 is 12, minus 2 times 3 is 6. 12 minus 6 does equal 6. So it checked out for the first equation. Make sure to check for both. So 2x plus 4y equals 20. 2 times 4 plus 4 times 3 gives us 8 plus 12, which does equal 20. So that also checked out. So this is a correct answer. X is 4 and y is 3. Some cases you may actually need to multiply both equations by a number. So choose the one that whichever variable you want to cancel out and figure out a common multiple that you would need to convert both of those coefficients to. So if we wanted to cancel out the x's, One multiple that I would maybe choose would be to turn both of them into 30. So one would need to be positive, one would need to be negative. Looking at the y's, if you wanted to convert those, one you could use a 6. So multiplying so that one is a positive 6y and one is a negative 6y. If we choose the y's and I want to change these so that one is positive 6 and one is negative 6, in order to rewrite this top one so that it's a positive 6, I would need to multiply through by a negative 2, because negative 2 times negative 3 would make that be a positive 6. So I would have to multiply that entire top equation by a negative 2. Now for this bottom equation, for this to equal a negative 6y, negative 2 times 3 would make that a negative 6. So I would have to multiply the entire bottom equation by 3. You could have changed the x's. You could have multiplied this by a negative 5 to get negative 30 and multiply this one by a positive 6 to get a positive 30, so that when they add, they cancel out. It won't matter which one you use. Just choose one of the variables and choose a multiple that they both would have, and then multiply through so that you have a positive and a negative. So rewriting my top equation, negative 2 times 6x, that would be a negative 12x. Negative 2 times a negative 3 would be a positive 6y. And then negative 12 times negative 2 would be a positive 24. In my bottom equation, I'm multiplying by 3. So 3 times 5x would be a positive 15x. Negative 2 times 3 would be a minus 6y. And then negative 13 times 3 would be a negative 39. So now, after multiplying through a common factor times the entire top equation and a common factor times the entire bottom equation, now I have opposite coefficients. Now I can just add the two equations. Negative 12 plus 15 would be a positive 3. These two cancel out. They equal 0. And then negative 39 or 24 plus a negative 39. Since they have opposite signs, you could subtract 39 minus 24. Since there's more negatives, my answer is going to be negative, and that equals a negative 15. So we have the equation 3x equals negative 15. Divide by 3 on both sides, and you get x equals a negative 5. Plug it back in to find y. I recommend using your original equations. Just that way you're less likely to make a mistake if you had made a mistake in the multiplying. So if we choose this bottom equation, 5x minus 2y equals a negative 13, and I plug in negative 5. 5 times a negative 5 minus 25 equals a negative 13, and you get negative 25 minus 2y equals negative 13, and adding 25 on both sides, these two cancel out. You're left with a minus 2y equaling 12, and then divide by a negative 2 to get y to equal a negative 6. So then you have both your solutions for x and for y. And it's important to do the check. And after checking both equations, it did come out to be a correct answer. So substituting in negative 5 for x and negative 6 for y. After applying the check with the original two equations, I would recommend using the original two, not the ones you changed. It worked out to be a correct answer.